Welcome to Factory on Air by DBR77, where smart manufacturing gets real. This is episode 10, Defining Production Capacity and Work Standards. Without accurate production capacity and realistic work standards, factories fall into chaos, with overloaded teams, missed deadlines, and unused potential. In this episode, we explore how simulation, real-time data, and digital twins help companies set the right benchmarks, balance resources, and plan with precision. You'll hear how manufacturers in electronics, food, and furniture industries improved their planning accuracy, resource allocation, and team performance. We'll also show how DBR77 models production capability under real-world conditions and help set work standards that actually work. Factory on Air is powered by DBR77, the AI-driven platform for operational clarity, strategic simulation, and production excellence. Let's get started.
Have you ever had that nagging feeling, that suspicion that your factory floor, maybe your logistics center, it isn't quite hitting its full stride?
Yeah, like there's hidden potential there.
Exactly. Like your production lines, your machines, your teams, they're capable of so much more, but something's holding them back. Or maybe you're constantly fighting those unexpected bottlenecks, grappling with resource allocation headaches, and it feels like you're always reacting, not optimizing.
Always putting out fires.
Right. You're planning, sure, everyone plans, but are you truly optimizing your potential? Getting the most out of what you have?
That's the million-dollar question, isn't it?
It really is. And if that resonates with you, you're tapping into one of the most critical yet really difficult challenges in industrial operations, truly nailing down your precise production capacity, and then setting realistic, effective work standards based on that.
It's a puzzle, definitely, and one that keeps a lot of companies from unlocking significant efficiency gains. Millions, potentially.
So we're diving deep into this today. We've got some fascinating material to guide our conversation. Our primary source is this really insightful document, Determining Production Capacity and Work Standards. It just lays bare the fundamental issues.
It's a great starting point, really foundational stuff.
And we're connecting that directly to another powerful resource, the detailed information we have about DBR77. That's this cutting-edge digital transformation platform.
Right, and it's built specifically to tackle these exact problems we're discussing.
Precisely. So let's set the mission for this deep dive.
Okay. Our mission really is clear. We want to show you why accurate capacity measurement has historically been so elusive, so hard to pin down.
Right.
We'll explore how advanced tools like simulation techniques and detailed data analysis are fundamentally changing the game. And critically, how integrated digital solutions, like the ones DBR77 offers, are engineered to directly address these complex challenges.
So moving beyond the theory.
Exactly. We aim to offer you a genuine shortcut, really, to becoming well-informed in this vital area, helping you move from relying on, educated guesses or gut feelings
That happens a lot.
to empirical, data-driven decision-making, the kind that actually unleashes your real production power.
Okay, let's start at the beginning then. Why has defining production capacity been such a persistent headache for so many plants? You might think, well, it sounds straightforward. Just count the units coming off the line, right?
If only it were that simple.
But here's where it gets really interesting and surprisingly complex.
Yeah, one of the biggest reasons is just the sheer complexity of the production processes themselves. Industrial operations aren't static, not at all.
They're constantly shifting.
Incredibly intricate systems, yeah, and constantly susceptible to a whole myriad of dynamic changes. I mean, think about it. A tiny, unexpected machine hiccup, even just for a few seconds,
Right.
that can ripple through an entire line, cause delays downstream. Or consider subtle variations in operator work pace, almost imperceptible sometimes throughout a shift. One person might be slightly faster, another a bit more deliberate.
Sure. Natural human variation.
Exactly. But that adds up. Over a day, a week, it can mean significant differences in total output.
Okay.
Or even shifts in the quality or consistency of your raw materials. That can throw off an entire process.
Right. If something's not quite to spec.
These aren't just minor bumps in the road. They are fundamental variables that significantly impact your actual real-world output. It makes pinning down a fixed capacity number incredibly difficult.
It sounds like trying to measure a river when its flow is constantly changing.
That's a great analogy. It's speed, depth, direction, all shifting.
And then there are the traditional methods people have used for decades. They often rely on theoretical assumptions, right? Idealized conditions.
Precisely. They assume every machine runs perfectly, 100% uptime. Every operator performs at peak efficiency consistently. Every single piece of material is exactly to specification, always.
Which, let's be honest, never really happens.
Rarely, if ever, does the factory floor match that perfect blueprint. These theoretical models, they often just fail to capture the real-world variables, the everyday disruptions, the unpredictable human elements, the mechanical quirks that are just part of any industrial setting.
So the plans end up detached from reality.
Totally. It leads to production plans that are, frankly, disconnected from what's actually achievable. And that creates this frustrating gap between what you think you can produce on paper and what you actually manage to get out the door.
And maybe the biggest issue, the biggest blind spot, is just not having the right data. That lack of comprehensive, granular information on what's really happening.
That's absolutely critical and often missing. We're not just talking about the final output numbers like units per day.
No, the details.
We're talking about the minute details, those insidious micro downtimes.
Ah, yes, the tiny stops.
Exactly, those tiny, frequent pauses might only last seconds, maybe a minute, but they accumulate exponentially over a shift, a day, a week. Our sources actually suggest these alone can eat up 15–20% of your theoretical capacity.
Wow, 15–20% just from those little stops.
It's huge, a blind spot potentially costing companies millions. And we're also talking about precise fluctuations in cycle times for individual operations. How long each specific step actually takes, not just some theoretical average.
Right, task by task.
Or the actual performance variations of specific pieces of equipment. You need to account for their age, their maintenance history, their inherent quirks. Every machine is slightly different.
Sure.
Without this precise, granular data, any capacity estimation you make is, well, at best, an educated guess based on incomplete info.
And at worst.
At worst, it's fundamentally flawed. It leads to this constant state of operational uncertainty. You just don't really know.
So for you, the listener, running an operation, what are the immediate consequences of these inaccuracies? How does this actually hurt the business?
Oh, the consequences are profound, and they hit your bottom line directly. Firstly, when your capacity is unknown or consistently misjudged, your production schedules just become inherently unreliable.
That you can't trust the plan.
Exactly. This often leads to missed deadlines with your customers. That damages your reputation, could even incur penalties.
Or the flip side.
Or, just as problematic, it can lead to costly overproduction. You end up tying up valuable capital in excess inventory that just sits there waiting for orders that haven't materialized yet. Huge waste.
Oh. What else?
Secondly, you end up with constant resource imbalances. You might find yourself with overworked staff and machines pushed beyond sustainable limits.
Leading to burnout, mistakes.
Burnout, increased errors, higher maintenance costs, absolutely. Or conversely, you have expensive assets, maybe specialized machinery, just sitting idle, not pulling their weight. That's a significant underutilization of capital.
So either overworking or underusing. Both bad.
Both scenarios directly impact profitability. Unnecessary operational costs on one side, missed revenue opportunities on the other.
And ultimately,
the inability to precisely define your true capacity means your plant simply isn't leveraging its full potential. You're leaving significant efficiency gains, cost reductions, competitive advantages just sitting on the table.
it's like that sports car analogy you used. Having the power but never really using it.
Exactly, driving it in first gear. So, this raises that important question, doesn't it? If the traditional methods fall short, how can we truly get a grip on what a factory can produce? How do we move past these issues?
That really is the core question. If those old ways aren't cutting it, how do we bridge that gap between the theoretical plan and the messy reality?
Precisely. And the good news is modern tools are providing some really powerful antidotes to this uncertainty. And right at the forefront of these solutions is simulation.
Simulation. Okay.
Think of simulations as providing a kind of virtual sandbox for your production planning, a safe space to play and experiment.
A virtual sandbox. I like that image.
Yeah.
So how exactly do these simulations let you map things out, test scenarios, without actually messing with your live operations?
Well, what simulations allow you to do is create a virtual mathematical model of your entire production process, or even your whole facility.
Like a digital replica.
Essentially, yes. It's often called a digital twin of your operations. And it's not just a fancy animation, it's a dynamic model. A living, breathing replica where you can experiment without any risk to physical production.
So no stopping lines, no risking materials.
None of that. No impacting deadlines. It's a completely safe environment for trying things out, for asking what if.
And what kinds of what-if scenarios can you actually run in this virtual world? Does it go beyond just predicting basic output numbers?
Oh, absolutely. It goes much deeper. Within this virtual mirroring, you can test an almost infinite number of scenarios. For example, you can simulate how machines perform under varying conditions.
Like different workloads.
Different workloads, yes.
Yeah.
Or even different maintenance schedules. You can see the precise ripple effect on your overall output. You can analyze the exact impact of adding or removing operators. Understand that delicate balance between staffing levels and throughput. How many people do we really need on this line?
Right, getting the numbers right.
You can even evaluate the effects of reorganizing the production layout. DBR77 talks a lot about value stream mapping and material flow planning. You can do all that virtually first, before you ever move a single piece of equipment or paint a new line on the floor.
That foresight sounds incredibly valuable, avoiding costly physical changes that don't work out.
It's truly revolutionary in that sense, the ability to test and optimize before committing resources.
So what's a tangible payoff, then, for a company investing in these pretty sophisticated simulations? What benefits do they actually unlock?
The benefits you gain are really profound. First, and maybe most importantly, through these simulations, you can establish a truly realistic, empirically measured production capacity.
Based on data, not just theory.
Exactly. This capacity number isn't just theoretical. It inherently accounts for those typical real-world disturbances and the variability that always plagues traditional methods. It gives you a number you can actually trust, a benchmark reflecting your real operational environment.
Okay, that's huge. What else?
Secondly, simulations allow for the proactive identification of bottlenecks and potential downtime before they ever happen in the physical world.
So you can see problems coming.
You can spot where queues might build up, where machines are likely to be strained, where human workflows create slowdowns. It offers critical, proactive insights. It lets you intervene and optimize before problems arise and cost you money.
Right, getting ahead of the curve.
And finally, by optimizing your layouts, your workflows, your processes virtually, you can significantly reduce operational costs and increase overall efficiency before you even implement the changes physically.
Less waste, less trial and error.
Much less wasted capital, fewer expensive mistakes on the physical floor, and a much smoother transition to those optimized operations. And what's really fascinating here is how this capability directly links to the core of what DBR77 offers, especially their digital twin technology.
Okay, that's a perfect connection. Tell us more about how DBR77 specifically leverages this digital twin concept.
Well, DBR77's digital twin functionality is all about creating that virtual and mathematical model of a real production plant or a logistics center. But they take it a step further. They integrate advanced 3D simulation with real-time IoT data.
So the twin reflects reality almost instantly.
That's the idea. As things happen in your physical plant machines running, materials moving, the digital twin updates. This allows for continuous monitoring and optimization in near real time. Users can test scenarios, identify bottlenecks in this constantly updated virtual environment, all without disrupting current operations.
Which leads to those cost reductions and efficiency increases we talked about.
Exactly. This virtual model faithfully reflects every production line, every machine, every material flow. It gives you an unparalleled, dynamic understanding of your entire operation.
That's powerful. And you mentioned stochastic analysis. What does that add?
Right, stochastic scenario analysis. DBR77 utilizes advanced algorithms for this. It basically means they can run thousands, even millions of what-if simulations that incorporate random, real-world variables.
Like unexpected breakdowns, supply chain issues.
Precisely. Things like unexpected machine failures, fluctuations in supply delivery times, even operator availability variations. By running these simulations with randomness built in, they can give you a true probability range of outcomes, not just a single deterministic prediction.
So it's more realistic about uncertainty.
Much more. This allows them to predict potential downtimes with greater accuracy and develop optimal implementation strategies that account for that uncertainty, anticipating issues before they become costly problems.
And the VRR integration, how does that fit in?
That's about making the simulations more intuitive and impactful. DBR77 integrates virtual reality and augmented reality. This allows managers, engineers, even operators to actually visualize the simulated solutions in a truly realistic, immersive environment.
So you can basically walk through your future factory.
Exactly. You can step into the simulation, see how the new layout feels, how the workflow operates. It minimizes implementation errors because people can understand and interact with the proposed changes much more deeply. And it fosters better understanding and buy-in among all stakeholders.
That's incredibly insightful, being able to virtually experience changes.
Yeah.
But okay, once we understand that broader capacity through simulation, how do we fine-tune things down at the individual task level? Which brings us back to work standards. What kind of data is absolutely critical for defining those effectively?
You've hit on a really critical point there, because understanding the big picture capacity is one thing, but making sure each step is efficient. That's where work standards come in. And the bedrock for truly effective work standards is unequivocally precise data.
Not just any data, but specific types.
Absolutely critical types of data. First, you need precise data on actual operation cycle times. How long each specific step or task actually takes on the line, repeatedly.
Not the theoretical.
Not the theoretical time, the actual time. Then you need accurate changeover times between production runs. Those periods where you switch from making product A to product B. How long does that really take consistently?
Okay.
And, crucially, granular information on all types of downtimes. This goes beyond just knowing a machine was down. It means knowing why it was down, for precisely how long and how frequently those tiny, almost invisible micro-stoppages occur.
Back to the micro downtimes.
They're key for standards, too. These core data points, actual cycle times, real changeover times, all downtime types. They're the fundamental building blocks for effective standards.
So it really emphasizes capturing what truly happens minute by minute, not just relying on assumptions or old estimates. What are the practical benefits then? Once you have this kind of data-driven work standardization properly in place, what changes for you?
The practical benefits for you are immense, really game-changing. Firstly, it allows you to plan production shifts with unparalleled accuracy. Meaning you know exactly what can realistically be achieved within a given time frame by a specific team or line. This avoids both the frustration and cost of overscheduling your teams.
Setting them up to fail.
Right. And it avoids the inefficiency of underutilization, where your valuable assets aren't working as hard as they could be.
Okay, better planning. What else?
Secondly, it enables clear, objective comparison of performance between different teams, different shifts, maybe even different lines doing similar work.
Apples to apples comparison.
Exactly. You can identify best practices, see who's excelling, and importantly, why, and then transfer that knowledge across your organization. It moves performance management away from subjective opinions towards hard data. You can pinpoint areas for improvement with real precision.
Makes sense.
Thirdly, you can set clear, measurable goals for improvement instead of vague targets like, increase efficiency next quarter.
Which are hard to track.
Very hard. You can say, we need to reduce the cycle time for this specific operation by 3 seconds, or reduce changeover time on line B by 15 minutes. This fosters a genuine culture of continuous optimization where progress is tangible, measurable, and can be celebrated.
People know what they're aiming for.
Precisely. And finally, and this is often striking, it leads to significantly reduced variability in performance.
Less fluctuation.
Much less. Take the example of that food producer mentioned in our source material. By implementing data-driven standardization of cycle times on their packaging line, they achieved a remarkable 25% reduction in performance variability between shifts.
Wow, a quarter less variation.
Think about that, a quarter less fluctuation in performance. That translates directly into increased consistency, much better predictability, and more reliable output day after day. And if we connect this back to the bigger picture, well, this is exactly where DBR77's advanced Internet of Things, their IoT solutions, come into play. They provide the critical raw material, that granular data for all these insights.
Right. So DBR77's IoT solutions are basically the mechanism for gathering that real-time granular data that's so crucial for setting these standards.
That's a core part of it, yes. DBR77 provides dedicated sensors and systems specifically designed for monitoring machine parameters and production processes right at the source.
Hardware and software.
Both. These advanced IoT solutions gather that precise, real-time data, the very data we just highlighted as indispensable for accurate standards and capacity analysis. This information is then fed into the system to identify inefficiencies, optimize workflow, and forecast production needs with incredible accuracy.
And the benefit is faster insights.
It ensures much higher data accuracy right from the source, and it significantly reduces the time needed for analysis. You get actionable insights faster, meaning you can react and improve more quickly.
How does this specifically benefit management? What's the value proposition for them from all this data collection? DBR77 emphasizes this, right?
They do, and it's crucial for management buy-in. Consider these 5 key points for management. 1. Precise performance measurement. Real-time data allows for accurate tracking of vital metrics like OEV, overall equipment effectiveness, and other KPIs. You get a true, up-to-the-minute pulse of your operations. No more waiting for end-of-shift reports that might be inaccurate.
Okay, real-time visibility.
2. Bottleneck identification. The data helps you pinpoint the specific areas causing delays or underperformance. You move beyond guesswork, I think the problem is here, to knowing precisely where the constraints are.
Finding the real culprit.
3. Proactive maintenance. This is huge. Predictive analytics built on this rich sensor data can forecast equipment failures before they happen. This enables preventative maintenance, minimizing costly unscheduled downtime, and extending asset life.
From reactive to predictive.
Exactly. 4. Optimize resource allocation. Understanding your true capacity and real-time performance allows for far better deployment of both your people and your machines, ensuring everything and everyone is working optimally where they're needed most.
Right people, right place, right time.
And 5. Evidence-based decision-making. This might be the most powerful shift. You move away from relying on intuition or gut feelings or historical anecdotes.
We've always done it this way.
Right. Towards making decisions whether for major investments in new equipment or for process changes that are supported by hard, empirical data. Defensible, logical decisions.
That sounds transformative, and you mentioned AI integration earlier. How does that enhance things further?
Yes, the AI layer. DBR77 integrates sophisticated artificial intelligence systems. These AI algorithms analyze the vast amounts of data pouring in from the IoT sensors and the digital twin. They learn from patterns, identify correlations, spot trends that a human might miss.
So they find the hidden inefficiencies.
They can proactively identify those subtle inefficiencies, yes. They can predict potential failures with even greater accuracy, and they can even suggest optimal courses of action in real time.
Like having a virtual consultant.
That's a good way to put it. The AI essentially acts as a virtual lean consultant, providing immediate, data-driven recommendations right when you need them. Furthermore, their machine learning algorithms are constantly developing. They even use synthetic data sets.
Synthetic data? What's that?
It means the AI can generate artificial data that realistically mimics real-world conditions. This allows the AI models to train faster and become more robust, especially when you might not have years of perfect historical data yourself. It leads to even more precise forecasting and optimization, constantly refining your operational insights and keeping the system smart.
So it seems DBR77 really brings all these powerful elements together, the detailed data from IoT, the virtual playground of the digital twin, the intelligence of AI into one cohesive platform. How does this holistic approach really enable that precise capacity modeling and the setting of those vital work standards we've been discussing?
Well, what's truly impressive, I think, is how DBR77 doesn't just offer one piece of the puzzle, right? It's not just simulation software or just IoT sensors. It's a whole ecosystem designed to tackle these challenges holistically end to end.
Okay.
So DBR77 directly addresses the concepts we've discussed by first creating that digital twin of a production line or even an entire plant. This isn't just a theoretical concept for them, it's a core practical offering. They take your physical reality and replicate it digitally with really high fidelity.
Building on that virtual mirroring idea. And once that digital twin exists, how does DBR77 specifically use it for advanced process simulation?
Right. Building on that twin, DBR77 employs truly advanced process simulation. This means it can simulate your production processes under a vast array of different conditions, much more than simple calculations.
Like what specifically?
Well, you can simulate the precise impact of potential failures. How does a single machine breakdown ripple through the entire system? You can model variable cycle times accurately, accounting for those natural fluctuations in human and machine performance we talked about.
Not just fixed averages.
Definitely not.
Huh.
You can even test different shift work models, maybe 3 shifts versus 2, or different team compositions to find the most efficient staffing patterns for different demand levels. This comprehensive simulation capability provides an unparalleled understanding of how all these different factors interact and influence your real empirical capacity. It gives you that crystal clear picture of what's truly possible under various scenarios.
And the data collection from the IoT system we discussed, that's continuously feeding into this simulation engine and the twin, right? It's not static.
Exactly right. It's a dynamic loop. Through its IoT system, DBR77 integrates the data collection and analysis seamlessly. It collects and analyzes that critical data operation times, those subtle downtimes, overall efficiency metrics. And this continuous stream of precise real-world data doesn't just sit in a database. It actively fuels the simulations. It constantly refines the digital twin, making it more accurate over time. And it provides the ongoing empirical basis for setting and, importantly, maintaining those accurate work standards.
A continuous feedback loop.
Precisely. Real-world data informing and improving your virtual models and your standards constantly.
So with all that integrated capability, the twin, the simulation, the real-time data, the AI, what are the ultimate outcomes? What can DBR77 actually deliver in terms of precisely determining capacity and standards?
The ultimate outcome, the goal of this integrated approach, is the precise determination of those key operational metrics that drive efficiency. Thanks to these sophisticated simulations and the robust data analytics, DBR77 can precisely determine your real production capacity.
Moving beyond theoretical maximums.
Far beyond that. Getting to what your plant can actually achieve consistently, accounting for all the real-world variables and disturbances. Secondly, it quantifies the impact of organizational changes.
Like testing changes before implementing.
Exactly. It allows you to measure, with data, exactly how changes in setup, staffing levels, process flow, or even new technology will affect your capacity and costs before you implement them. This saves huge amounts of time and avoids costly mistakes. And finally, it helps you define the most optimal work standards. Efficient and realistic standards for various production scenarios, ensuring that your teams are set up for success with achievable, data-backed goals, not just arbitrary targets.
That really does sound like a comprehensive ecosystem.
Yeah.
How does DBR77 manage to achieve that level of interconnectedness? And you mentioned automated decision-making. How does that work across all these different aspects?
Yeah, that interconnectedness is a crucial distinction. DBR77 isn't just standalone software. They position themselves as an entire ecosystem. A key part of this is how they connect partners companies delivering robotic technology, automation solutions, with integration companies who implement them.
So bringing the whole supply chain together.
In a way, yes. Information from these partners about the latest technologies is used within DBR77's platform. This allows them to present the newest, most relevant automation options to you, the production company. And critically, it helps optimize your processes based on precise data informed by what's possible with current technology. It's a living network of innovation, not a static tool.
Interesting. And the automated decision-making part.
That's another cornerstone. Based on advanced language models, think sophisticated AI understanding context and statistical analyses of all the data. The DBR77 system can automatically generate detailed reports and clear, actionable recommendations.
So it tells you what to do.
It provides strong suggestions. This empowers managers to make swift, informed decisions, and it helps them dynamically adapt operational strategies much faster to changing market conditions or internal performance shifts. Imagine having a real-time advisory system analyzing complex data and flagging up, here's an issue, and here are 3 potential solutions with their predicted impact.
That speeds things up considerably.
Tremendously. And underpinning all of this is what DBR77 calls their unique technological ecosystem. All their technologies, the IoT, the twin, the AI, the marketplace interface, are designed for incredibly easy implementation and rapid scalability.
Meaning it works for different company sizes.
Exactly. They stress adaptability to any plant size or production specificity. Whether you're a smaller SME or a large multinational, this holistic approach covers every crucial aspect, from the initial data collection through the sophisticated analysis and simulation, and right through to automating decision support. It provides a complete, integrated solution for digital transformation in this area.
Okay, so we've covered the technology, the processes, the data, the ecosystem.
Yeah.
Now let's bring it right back to you, the listener. What are the profound, measurable, tangible benefits you can realistically expect when you implement these precise work standards and get a true handle on your capacity, especially with a system like DBR77 helping you achieve all this?
Let's list them out because they're significant. First, you get truly precise resource planning.
No more guesswork.
Right. This enables meticulous planning of both your people, your human capital, and your expensive machine resources. It eliminates guesswork, ensures every asset is deployed optimally. No more idle machines sitting next to overworked staff because the schedule was based on bad assumptions.
Okay, that's a big one. What's next?
Second, you'll see a direct reduction in downtime. By accurately understanding your real capacity and setting precise, achievable standards, you minimize downtime caused by inefficient scheduling, unexpected bottlenecks that could have been predicted, or just a lack of clear operational procedures. Problems are foreseen and averted, or at least mitigated, much faster.
Less firefighting, more prevention.
Exactly. Third, it facilitates accurate work accounting and granular analysis of performance deviations. You can pinpoint exactly where and why performance might be straying from the standard. This allows for targeted, surgical improvements instead of broad, often ineffective, try-everything initiatives. Accountability becomes clearer, and the path to improvement becomes obvious because it's based on data.
Makes sense. What about bigger decisions?
Fourth, it provides robust data for better investment planning. This is crucial. When you're considering investing in new production lines, new machinery, expensive automation, you're no longer relying on rough estimates or supplier promises alone.
You have your own data.
You have hard empirical data from your own operations, simulated with the new technology perhaps, to ensure that capital is allocated where it will genuinely yield the greatest return on investment. It makes your strategic financial decisions much more robust and defensible.
And there was a fifth benefit.
Yes, and it's a powerful one, often overlooked. Improved team morale.
How so?
Think about it. When expectations are clear because standards are data-driven and realistic, when work is planned effectively so people aren't constantly rushed or facing impossible targets, and when performance evaluation is objective and fair, it fosters a much more positive and productive work environment.
People feel set up for success.
Exactly. Teams understand what's expected, they feel they can achieve their goals, they see fairness in how performance is measured, and they feel a greater sense of accomplishment. This leads directly to higher morale, better engagement, and often lower turnover.
That's a really important human element. And these aren't just theoretical benefits, right? The source material had examples.
Absolutely not theoretical. Our source document provides concrete examples that really drive these points home, illustrating the real-world power of this integrated data-driven approach, like the one DBR77 champions. Take the mechatronics plant they mentioned.
What happened there?
Through detailed analysis, digging into that granular data and running simulations, they were able to increase resource utilization on their assembly line by a remarkable 18%.
18%? That's huge.
It's massive. Imagine the impact that could have on your bottom line. That's nearly a fifth more output from the very same assets, the same people, just by truly understanding and optimizing their capacity and workflow.
Wow. Any other examples?
Yes, consider the furniture factory. For them, achieving precise capacity determination allowed them to much better forecast their seasonal order fluctuations.
You're common in furniture.
Very common. And as a direct result of that better forecasting based on real capacity, they significantly reduced their inventory levels.
It's freeing up cash, reducing storage.
Exactly. It frees up working capital, cuts down storage costs, and minimizes the risk of having obsolete stock sitting around. It helped them move from a more reactive stockpiling model towards a leaner, more demand-driven operation. Real financial benefits.
In connecting this back to DBR77 specifically, you mentioned their marketplace earlier.
Right. When we think about investment planning, that fourth benefit, the DBR77 marketplace, comes into play again. Their data suggests it can shorten the automation implementation time by half and potentially save 30% of costs during the purchase and implementation phase. That's compared to the average, often lengthy, 25 months for traditional automation projects.
Cutting time and costs significantly.
Hugely. So if we connect this to the bigger picture, these aren't just abstract ideas or nice-to-haves. These are real, tangible gains in efficiency, cost savings, and speed to market. They translate directly into competitive advantage in today's demanding industrial landscape.
Those benefits are certainly compelling. No doubt about it. But of course, implementing such transformative solutions, shifting to this data-driven approach, it isn't always easy. It's not without its challenges, is it?
Absolutely not. Smooth sailing is rare in major operational changes.
Even with the best intentions, the most advanced tech, there are typical roadblocks companies run into. So let's unpack some of those common hurdles. What challenges do companies typically face? And crucially, how has DBR77 specifically built solutions for those challenges? They seem to have thought about the implementation journey.
They definitely seem to have considered the practical roadblocks, yes.
Yeah.
Because technology alone isn't enough, right? You have to
Yeah.
address the implementation reality. We can probably group the challenges and solutions into a few key areas.
Okay. Where should we start? Maybe with the data itself.
Good place. Let's call it data acquisition and quality challenges. One major issue we've touched on is process variability. Every little change, a new batch of material, a different operator having a slightly off day, a tiny adjustment to a machine parameter, it all affects efficiency. It's this constant battle against tiny fluctuations that mess up your predictions.
Hard to model accurately.
Traditionally, yes. DBR77's solution. Well, as we said, their advanced IoT sensors gather that granular real-time data on these micro-changes. But crucially, their AI algorithms don't just track it. They learn from historical data, identify patterns in the variability, and can even generate those synthetic data sets we mentioned to train predictive models more effectively.
So they account for the variability.
They aim to account for it, predict it, and manage it rather than just being surprised by it. It improves forecasting significantly.
Okay. Another data challenge you mentioned was collecting micro downtime data, those tiny stops.
Right, the difficulty collecting micro downtime data. These little stoppages add up to massive time loss, but they're often completely overlooked in manual tracking or just incredibly hard to capture accurately and consistently.
Too small, too frequent.
Exactly. DBR77's solution here is twofold. First, they offer both dedicated hardware sensors and sophisticated software systems designed specifically to precisely collect this data from production lines and individual workstations. They focus on capturing reality.
And the second part.
Second, they acknowledge you might not have perfect data from day one. So they also provide a standard database for preliminary simulations. Even if your live data is incomplete initially, you can use this standard data to run early simulations, identify the likely major issues, and prioritize your improvement efforts. It's about getting value quickly, even in imperfect data environments, while you build up your own specific data.
Getting started even without perfect data. Okay, that makes sense. What about the human side, the organizational challenges? Let's call them implementation and adoption hurdles.
Absolutely critical area. One significant hurdle, and it's a sensitive one, is organizational resistance to revealing real efficiency.
People don't want to look bad.
Let's be honest, yes. Companies, departments, even individuals can be hesitant to expose their actual efficiency levels, especially if they suspect they're lower than perceived or reported. It can feel like exposing a weakness or inviting criticism.
Understandable, but hinders improvement.
Totally hinders it. DBR77 seems to address this directly with what they call a human-centric approach. They emphasize making the system simple and intuitive to use. They also provide extensive educational materials, case studies showing success elsewhere, their DBR77 Academy for training, webinars explaining the why.
Building understanding and trust.
Exactly. The focus isn't framed as exposure or blame. It's squarely positioned as being about improvement, finding hidden gains together, making work easier and more productive for everyone. Reducing that inherent fear is key.
Okay. What other adoption hurdles?
Another common one is simply the high manual data collection effort required without automated systems. If you try to do this kind of granular analysis manually, it becomes prohibitively time-consuming. Just collecting and crunching the numbers is a full-time job, making it impractical for many businesses.
The analysis paralysis problem.
Right. DBR77's solution. Well, the platform is built to automate that data collection via its integrated IoT system. And it uses AI-driven analysis to do the heavy lifting of sifting through the data and finding insights. That takes a huge burden off your internal teams.
And technically, is it hard to integrate?
They've tried to simplify that too.
Yeah.
The platform runs in a browser-based environment. That drastically simplifies deployment because it typically doesn't require complex modifications to your company's existing IT infrastructure.
No big installs on every computer.
Yeah, generally no. And for connecting to your existing systems, like your ERP for orders, MES for production control, WMS for warehouse data, They manage integration via a carefully designed API application programming interface. This is designed to minimize the time, cost, and risks usually associated with integrating different software systems.
Trying to make it less painful IT-wise.
That seems to be the goal.
What about companies that are completely new to this? Is there a high entry barrier for digitization newbies? Many traditional manufacturers might find concepts like digital twin and IoT pretty intimidating.
That's a very real concern, absolutely. DBR77 seems to tackle this by focusing hard on ease of use. They claim most functionalities can be learned and used effectively after just a few hours of training.
Lowering the learning curve.
Yes. And critically, they use a subscription model with a relatively low entry cost. This minimizes the upfront investment risk. Companies can start with a pilot project, maybe on just one line or area, see the ROI quickly, and then gain the confidence and justification to scale up to a full implementation. Demonstrating value fast is key for newbies.
Pilot projects make sense. Now, shifting gears slightly, what about the broader market and strategic positioning challenges? This is a hot area. Big players like Siemens, ABB, Schneider Electric are heavily invested here. How does DBR77 compete?
That's a fair point. It's a crowded and competitive space. DBR77's strategic counter seems to have been quite clever initially. They deliberately focused on small and medium enterprises, SMEs.
A segment often overlooked by the giants.
Often, yes. Larger providers sometimes see SME projects as too small or requiring too much customization for the return. DBR77 targeted them by offering that simplified deployment, faster ROI, and the lower entry cost via subscription. This allowed them to gain significant traction and build a user base.
And now they're attracting larger companies too.
Apparently, yes. Their flexibility, the perceived simplicity, and that subscription model have also proven attractive to larger corporations looking for agile solutions or ways to pilot digitalization without massive upfront capex. So their initial niche focus seems to be scaling effectively.
Interesting strategy. What about the long sales cycles often seen in industry? That must be a challenge.
Definitely. Long decision cycles in industrial clients are notorious. Industrial purchasing decisions are often multi-stage, involve many stakeholders, require extensive justification. It can take months, even years.
So how does DBR77 speed that up?
Their emphasis on pilot projects is key here too. Allowing companies to quickly validate the effects on a small scale with lower risk helps accelerate the decision process. Seeing tangible results on one line makes it much easier to get approval for wider rollout. And again, the subscription model avoids the huge upfront cost barrier, making the initial yes easier to get. Low barrier to entry, high potential ROI, that's the pitch to shorten the cycle.
Okay. Another challenge must be implementation itself. You need partners, right? Integrators.
Absolutely. There's a definite need for a strong integrator network. Digital and automation solutions rarely work out of the box. They require collaboration with technology providers, robotics, sensors, and skilled integrators who can actually install, configure, and customize the solutions on the factory floor. A lack of this network can stall everything.
So how does DBR77 handle that dependency?
This is where their marketplace comes in again, and it seems quite central to their strategy. They boast connections with over 800 technology suppliers and 600 integrators directly through their platform.
Wow, that's a lot.
It makes it one of the largest platforms of its kind, they claim. This provides their clients with almost instant access to a wide range of specialists and pre-vetted solutions, all within a sort of one-stop shop model. It drastically simplifies finding the right partners for implementation.
Removing a major implementation bottleneck. What about data security, especially with cloud platforms?
Huge concern. Cloud data processing concerns, particularly around legal compliance like GDPR and general data security, are top of mind for industrial clients dealing with sensitive operational data.
Understandably so.
DBR77 emphasizes they operate under the highest security standards, specifically citing ISO 27001 certification. Their data is stored on AWS servers located in Frankfurt, Germany, which is crucial for complying with stringent European data protection regulations like GDPR.
And the B2B nature.
Yes, they stress it's a strictly B2B platform. All users, the manufacturers, the suppliers, the integrators sign mutual non-disclosure agreements, NDAs. This legally protects not only the manufacturer's production data, but also sensitive commercial information from the integrators and suppliers within the marketplace. They seem very focused on building a secure, trusted environment.
Okay, they seem to have answers for many common domestic challenges. What about going global? Difficult international expansion is often a hurdle. Different rules, taxes, standards.
True. DBR77's approach here seems to be leveraging their network. They actively collaborate with local integrators and distributors in different countries, many of whom already operate internationally. This partnership model helps them adapt the platform and their approach to local regulations, tax systems, and technical standards, essentially using local expertise to facilitate expansion and accelerate market entry abroad.
Using partners to navigate local complexities. What about the pressure for financial results? Industrial firms demand clear savings, right?
Oh, absolutely. High ROI expectations from clients are standard. Industrial firms need to see clear, preferably fast, financial savings or performance gains to justify investments.
So how does DBR77 deliver that quick ROI?
Several factors contribute. The lower initial cost due to the subscription model helps the ROI calculation look better sooner. The integrated marketplace helps clients select the most cost-effective and technically optimal solutions for their specific problem, avoiding overspending or choosing the wrong tech. And faster implementation, which the platform aims to facilitate, means you start seeing the benefits, like that 18% utilization increase or reduced inventory much sooner, leading to quicker payback.
Makes sense. One last challenge. This field moves fast. AI, digital twins, they evolve constantly. How do they avoid becoming outdated?
That's the challenge of continuous development of a digital twin. Stagnation in this field means quickly losing your competitive edge. DBR77's answer seems to be built around continuous learning and integration. They thrive on dynamically collecting vast amounts of data, both real data from clients and generated synthetic data specifically for training and improving their AI algorithms.
Keeping the AI sharp.
Yes, and their direct cooperation with hundreds of technology suppliers and integrators via the marketplace ensures they have constant updates on the latest hardware, sensors, and automation solutions coming to market. They can then integrate capabilities like their spatial analysis functionalities, allowing integration with the latest AI vision models to keep the platform at the forefront. It's about building an ecosystem designed for ongoing innovation, not just a one-time solution.
It really sounds like a comprehensive approach, thinking through not just the tech, but the whole business and implementation journey for you, the customer.
That seems to be the intention, yes. To anticipate and proactively solve the very real challenges that have historically hindered digital transformation in many industrial settings.
Okay, that's a really thorough look at the challenges and how DBR77 approaches solving them. So let's bring this back home. What does this all mean for your next steps? If you're listening to this and thinking, okay, I want some of those benefits, how can you practically apply these insights to unlock your own production power? What's the pathway?
Based on everything we've discussed and reflecting DBR77's methodology, there's a pretty clear pathway with actionable steps. First, you absolutely have to start by collecting real data.
Getting the foundation right.
Exactly. Gather actual cycle times for your key operations, measure your real downtimes, categorizing them properly, track your actual changeover times. This foundational step, getting accurate baseline data, is often skipped or done poorly, but it's absolutely crucial. You can't improve what you don't accurately measure.
Okay, step one, real data collection. Then what?
Second, you need to analyze micro downtimes and deviations. Don't just look at the big numbers. Dive into those granular details. Why did the line stop for 30 seconds? Why is shift B consistently 5% slower on this task? Uncovering these hidden inefficiencies and the deviations and the small stops is vital. That's often where the biggest gains are hiding.
Find the hidden waste. Got it. Step three.
Third, based on that data, you create a digital twin. Build that virtual replica of your plant, or maybe just start with one critical production line. This virtual model becomes your safe experimental sandbox, reflecting your operations with high fidelity based on the real data you collected.
Your virtual factory.
Precisely. Fourth, you then use that twin to simulate different production variants. Test various what-if scenarios. What happens if demand doubles? What if we add another machine? What if we change the staffing model? Run these tests virtually to predict outcomes and identify the optimal configurations without disrupting your actual production.
Experiment safely. Makes sense. Step 5.
Fifth, based on all that real-world data and the insights from your simulations, you define realistic standards. These are empirical work standards and performance goals. They need to be achievable, fair, based on data, and directly contribute to maximizing your now understood true capacity. This replaces those old theoretical assumptions or arbitrary targets with data-backed goals.
Setting achievable targets. And the final step.
And sixth, crucially, this isn't a one-and-done project. You need to implement continuous monitoring and updating. Regularly track performance against the new standards. Continuously collect data to keep the digital twin accurate and relevant. Analyze deviations ongoingly. This regular tracking and analysis ensure your standards remain accurate, your twin reflects reality, and you drive ongoing iterative improvement throughout your operations. It becomes a continuous improvement cycle.
Right. It's a process, not a single fix.
Yeah.
So when all these steps are implemented correctly, ideally with support from a platform like DBR77, what's the ultimate impact? How does this really change a company's production planning day to day?
The impact on your production planning is massive, truly transformative. What does that mean for you directly, practically? Well, first, it means vastly improved order and schedule planning.
Well, reliable plans.
Much more. Real capacity data enables you to create far more accurate plans for your incoming customer orders and your entire production schedule. This leads to greater reliability, better customer satisfaction, and fewer panicked calls from sales asking where an order is.
Okay, what else?
It means shorter lead times. Because you can plan more precisely, identify and remove inefficiencies proactively, and smooth out the workflow, you can fulfill orders faster. That's a significant competitive edge in many markets.
Faster to market. Good.
It significantly reduces risk. It minimizes the danger of both underestimating your capacity, leading to missed deadlines and lost sales, and overestimating it, leading to excess inventory, wasted resources, maybe even layoffs if demand doesn't match. Both extremes are costly mistakes rooted in not knowing your true capability.
Managing risk better.
Definitely. You achieve optimal resource utilization. This ensures that both your people and your expensive machinery are used as efficiently as possible at minimal cost. You're maximizing the output you get for every unit of input, every labor hour, every machine hour, every euro or dollar spent.
Getting more bang for your buck.
Essentially, yes. And the sum of all these parts, it leads to overall operational excellence. It means your operation becomes more agile, more responsive to change, more cost-effective, and ultimately more competitive in the marketplace. You're better equipped to adapt to market demands, handle disruptions, and seize new opportunities because you have a deep, data-driven understanding of your own capabilities.
That's a powerful summary of the potential impact. As we wrap up this deep dive then, the core message seems crystal clear. Understanding and actually leveraging your true production capacity through precise data, advanced simulation, tools like digital twins. It isn't just some nice-to-have advantage in today's industrial landscape. It feels absolutely essential, doesn't it? Essential for navigating the dynamic, ever-changing nature of modern manufacturing and logistics.
I completely agree. The days of relying solely on guesswork, historical averages, or overly optimistic theoretical calculations are rapidly fading. They're just not good enough anymore to stay competitive. And platforms like DBR77, they really do represent a new era of digital transformation in this space. They're not just offering isolated tools, they're seamlessly integrating these powerful technologies, the Internet of Things for real-time data, digital twin modeling for virtual testing and understanding, and artificial intelligence for analysis and prediction to provide a truly comprehensive ecosystem. An ecosystem aimed squarely at achieving operational excellence and enabling strategic growth.
Empowering better decisions.
Ultimately, yes. It's all about empowering you, the listener, the manager, the engineer, to make smarter, faster, and ultimately more profitable decisions. Decisions made in real time based on empirical truth derived from your own operations, not just based on historical patterns or abstract theories. The true insight, I think, isn't just knowing your static capacity number, it's gaining the agility to dynamically understand and adapt it, turning every operational variable, every potential disruption, into a predictable input for strategic planning and growth.
That's a great way to frame it. So, as you reflect on our conversation today, here's a final thought to consider. What hidden inefficiencies, what pockets of lost time or wasted resources are currently lurking in your operational data, just waiting to be revealed by these kinds of advanced digital tools? And perhaps more importantly, how much untapped potential is there for rapid transformation, for significant competitive advantage, if you could truly know your capacity second by second and empower your teams with precise, achievable, data-driven work standards? We really encourage you to explore this further, maybe by looking into digital transformation tools specifically designed for your industry or operational challenges, or perhaps just start by revisiting your own operational data, even the data you already have, but look at it with a fresh analytical eye, asking some of these harder questions. The answers might surprise you.